Thank you for your interest in our LoRa tester RWC5020A. Our tester support end device test and gateway test too. Uh, in this video clip, I'm gonna show you the real demonstration with end device. So this is the end device, it's a DUT, and then our tester becomes the gateway and network server. So let me start the testing. When you push main menu button, it shows the main menu. So from here, you can select the end device test or gateway test. So the first one is for end device test. Second one is for gateway test. Now I'm gonna test the end device. So let me select end device test mode. In end device test mode, it has 4 sub-menus: link analyzer, power time, power channel, sensitivity. Using the link analyzer, you can record all link messages between your end device and our tester. And power channel, using power channel, you can measure the TX power of your DUT. Using the sensitivity, you can measure the RX performance of your DUT. So let me start from link analyzer. If you push parameter button, you can configure LoRa protocol parameters. The first one is the region. As you see, our tester support almost all region: Europe 400 megahertz, US, Canada, Austria, China, Korea, Asia, India. You can use these parameters. You can test for almost all regions. Now I'm gonna test the end device for Europe. So let me select the Europe 800 megahertz. And our tester support protocol 1.0 and 1.1. So you can select one of them. And also it support class A, B, C. All classes are supported by our tester. And of course, you can select the activation method as OTAA or ABP. And there are a lot of protocol parameters, so you can test almost all protocol functionalities using our tester, because we support almost all protocol parameters from our GUI. Even our tester can transmit MAC command. So you can see the many MAC commands defined. So select one of them and then you can transmit this MAC command to your end device. I want to show you real demonstration about this one later. Okay. Let me turn on the end device. Actually, you can just push. You need to push just the run button. That's all. Then our tester ready to receive the message from end device. Now you see that end device transmit join-cast message to our tester. Tester is gateway and network server emulation mode. So our tester replied with join accept message. After that, DUT transmit uplink message, and then our tester transmit activate test mode MAC command to make the DUT as test mode. So now DUT transmit downlink counter packets every 5 seconds. And from this screen, you can get many protocol information as well as baseband packet information. You can see channel number, spreading factor, bandwidth, power, and the time between uplink message, and frame counter, ADR, EC, like that. Almost all informations are on the screen. If you would like to get more information, you can use the binary data. As you see, it shows the binary data too, so you can get more information from the binary data if you need. Now I'm gonna explain you about the power time. you can see the power time graph, and then now the point is increasing because now we are receiving packets from DUT still, and then it shows the maximum, minimum, average powers of your DUT. It's a real measured value, and then it shows the spreading factor powers. Now that DUT used the spread factor 12 and the spread factor 7, so it shows two values. If DUT use the different spreading factors, in the case, our test will show all spreading factors power. And if you using the cursor, you can select the point, the power point. In the case, you could see the packet information on the screen. This information is matched with link analyzer, so you can compare with link analyzer information and then this information. And using the power channel, you can measure the channel flatness. We are measuring the channel powers and then shows the maximum, minimum, average values of for each channel. So far, I explained about the link analyzer and then power time, power channels. And then let me start the sensitivity. Sensitivity is for RX performance of your device. So our tester measures the packet error rate. In this example, our tester will test with minus 40 dBm, from minus 40 dBm to minus 140 dBm. And at each point, our tester will measure the packet error rate and then shows the graph. Let me show you a real demonstration. Let me change the parameters, the range of powers. Push the parameter button, and then you can set here, you can set the start power and stop power, and then even packet numbers. Every parameter, almost all parameters are editable. So let me select this one as minus 120 dBm. And okay, and then let me set the packet numbers as 5. If we increase these values, in the case the test result will be better, but it takes much more time. So in this example, in this demonstration, I want to use just 5 packets per each point. Just push run button, that's all. Now test is started, and you can see, you can get the state information from here. Now it testing 3 times, 4 times, but there is no error still. So it shows the 0 error. And as I told you, I set the packet numbers as 5. So at each point, it tests 5 times, and then it calculate the packet error rate. And then after that, decrease the TX power of our tester. So now it is testing with minus 122 dBm. And then there was no error, and then reduce again as minus 124 dBm. It tests like these ways. While you are testing the sensitivity, actually, you can move the windows, like a link. You can go link analyzer, and you can see the link messages between tester and the device. And even power time, power channels are working simultaneously. So you can return to the sensitivity, and then it's still learning the sensitivity. So you can get more information from link analyzer, power time, and power channel. sensitivity test is done, from this graph, you can see that the DUT can receive up to minus 138 dBm signal, but it lost all packets with minus 140 dBm signal. So I can say that the sensitivity of this DUT is minus 138 dBm. So as you see, using the link analyzer, you can check the protocol interoperabilities and then protocol functionalities. And using the power time, power channel, you can measure the TX performance of your device. Using the RX sensitivity, you can measure the RS performance of your device. So you can test almost all things using our testers for your LoRa device. Let me show you one more real demonstration about the Mac command testing. As I told you, our tester can transmit Mac command to your device. So let me select device status request and just push a Mac send button. In the case, as you see, our tester transmit device status request to end device, and then end device replied with device status answer. Like these ways, you can test almost all Mac command behavior of your device. And then our tester even transmit multi-Mac command. It means that you set the number of command as 2 or 3. In the case, you can transmit 2 or 3 Mac commands in one single frame. So we provide a very powerful protocol test function. So far, I explained about the end device test mode. For gateway testing, actually is the very similar to end device test. Just the role is changing. If you select end device test, our tester becomes the gateway and network server emulation mode, and then it will communicate with your end device. If you select it as a gateway, in the case, our tester becomes the reference end device, and then it will communicate with your gateway, and then while communicating, our tester will record all link message and then will measure the TX power of your gateway and then measure this RX sensitivity of your gateway. So test method is the same as end device test. So I'm gonna skip this one. The last one is non-signaling test. This is for manufacturing actually. If you select the non-signaling test mode, our tester becomes like a signal generator, and then our tester will transmit some fixed pattern continuously. So it can be used in manufacturing line to measure the RX sensitivity. If we are using non-signaling test mode, you can measure the RX sensitivity very quickly, but it requires test mode in your device. Also, we support signal analyzer mode. If your device can transmit fixed pattern continuously, in the case our tester will receive the packets and they measure the powers. So it can be used in manufacturing for fast testing. So far, I explained about LoRa testing with our RWC5020A without a PC application program. And next video clip, I'm gonna introduce you about our PC application program. If we are using PC application program with our testers, our PC application program support many automation methods, so you can get more test result using our PC application program. Thank you.